Yeah. Oh yeah, definitely.
I don't think I am.
I think you are. You'll see.
I am.
So
Really
two very easy questions, and they have to do with water.
Okay.
So the first question here, I have 3 water bottles, and I have them halfway filled with water, and I painted the water blue with food coloring just to make it easier to see.
Okay.
So there's also a red ping pong ball in there.
Yeah.
Another thing to note is that all of these water bottles are at rest.
Okay.
So, but how I'm showing them to you, what's the difference between these 3 water bottles?
They're a different orientation.
Yes, you guys got it. Can you put them in the correct orientation? It should be.
Like,
like sideways.
You guys got it?
Yeah.
Yes, you guys got it. How'd you guys know?
Wow. Well, the density.
Yes.
That's probably what, like oil or something, or I don't know.
The density layering,
Yeah,
you
the
could say that.
density.
Yeah, the most dense goes to the bottom, which is water, and the less dense goes to the top.
Yep.
Yeah,
Okay, wow.
exactly. So you guys got it. Pretty easy, right?
Smarter than fifth graders.
Yeah. The second one, I think is a little bit easier, so you guys should get it.
We'll see.
So again, I have a box truck halfway filled with water.
Okay.
Again, but in this one, only one of the box trucks is at rest. One is accelerating forward, and one is accelerating in reverse. So which one of these 3 is at rest?
Okay. B.
Okay, why is B at rest?
The water is still
Okay.
on the bottom.
Okay, perfect. Which one's accelerating forward?
This one.
Yes, YA.
Water in the back. Yeah.
Exactly. So because of inertia,
Yes.
again, the water inside a container wants to remain where it's at rest. So when you accelerate, again, the water always pushes back in the opposite direction. Even when I accelerate down, the water wants to push up. Because water always reacts to acceleration.
Right. Yeah.
So now let me ask you guys this question.
Okay.
When I'm holding this and it's at rest, and I release it into free fall, do you guys believe gravity pulled it down to the ground?
No, the water. Wait.
Do you believe
I mean, yeah.
gravity accelerated?
Yeah,
exactly, right?
Yeah.
So when I actually accelerate versus free fall, I actually have a slow motion demonstration here. When I actually accelerate versus free fall, the water actually reacts to the actual acceleration. It wants to push back in the opposite, which is what water does. In free fall, however, there is no reaction of acceleration. There are no effects of a force in free fall. So I don't know if you guys knew gravity is just a theory, and the reason why.
I know it was a theory. Yeah.
And the reason why is because there is no physical measurement of downwards acceleration. So another thing we know there is no physical downwards acceleration is everybody's cell phone has an accelerometer app. So that's how you're able to turn it sideways and upright, because there's an accelerometer in there. So if you download an acceleration app on your phone and you accelerate that phone left, right, up, or down, it doesn't matter what direction you actually accelerate it, the app is going to register that force. When you put that phone into free fall, though, however, it registers 0 acceleration. So what it registers is a deceleration from 1g. Because when it's on Earth here, it experiences a force of 1g. But when it's in free fall, it goes from 1g to 0. So it's a deceleration. So what's happening is, you guys obviously were taught that gravity is a pulling force that pulls you to the ground. The reality is the Earth is pushing up against you.
Right, and I've heard that too, but I thought it was like they were working against each other.
So
and that's why we're sedentary.
So what's happening is inertia, again, matter wanting to remain motion is the reason why water always pushes back, is your body wants to remain motionless, so the Earth pushing up against you because of inertia is resisting that push, so that's why you have weight. It's the inertia is the equal and opposite reaction to gravity.
You're like reminding me of my high school physics.
No. So again, you guys believe the Earth is a globe, right?
For sure.
Yeah.
So,
yeah, of course.
We're not flat earthers.
Okay, so if we can prove that gravity is not a pulling force that accelerates objects towards the Earth, and it's the Earth literally moving up to the object, because that's the only way it's able to push up against you, how would the Earth moving up work from a globe? If up is relative on the ball. I'm sorry?
What's the question?
So again, if we can prove that objects don't accelerate down towards the Earth, and it's literally the Earth moving up to the object to compensate for that gravity visual, if we can prove that it's the ground moving up, and up is relative on a ball, for example, if you're standing here, up is this way. If you're standing here, up is this way. And how can the Earth be moving up on a ball if it was a ball?
It's moving out from the center.
So it'd be expanding, right?
Yeah.
So in other words, it wouldn't work. That's the point.
Well, expanding how?
Well, it will be expanding into infinity, growing.
Yeah, and it does.
So you think the Earth is growing?
No, but I think the force it enacts goes as far out to the speed of light.
What does that mean?
The action of gravity, the force of gravity, nothing can move faster than the speed of light.
Okay, what does it have to do with the upwards push over here?
Because how far it acts out, the force acts. We have a pull on the moon, right? And Earth. So as long as...
Let me ask you this. I know where you're kind of going with this, but this is going to make me clear things up in your head. You know what buoyancy is? You guys know what something floats in a medium that's more dense than the object, right? So buoyancy, when you release a helium balloon, what direction does it go? Why does it go up?
It's going out from the center of.
I have
Sure, but why does a helium balloon move up when you release? Why doesn't it go left or
lighter
right?
than air.
weightless?
Okay. Yeah, because it's lighter than air. So the air is more dense than the helium. But my question is, I agree with that. But why does the helium move? What about the density of the air being more dense than the helium make it go up? Why doesn't it go left, right, or down?
Because pressure.
Pressure, exactly. Pressure. You know, pressure is a push. So when you apply pressure on something, you're literally pushing up against it. So I recreated buoyancy in a cargo van, for example, here. If you guys want to see. So I put a helium balloon in a cargo van and an apple. So the helium balloon is less dense than the air and the apple is more dense than the air. So I accelerated the van in a particular direction.
Whoa.
What direction did it accelerate? Right or left?
To the left.
I think you did to the right.
To the right.
Yeah.
Exactly.
Yeah.
So what happened when I accelerate to the right, the air again has inertia, so it wants to remain where it's at. So the van moving the air, pushing up against the air, creates a pressure gradient in the van. So the most dense air gets pushed towards the back, and the less dense gets pushed towards the front. So the air is able to push the helium because it's less dense in the same direction the air is moving. So when we release a helium balloon here on Earth, again, the apple only appears to swing back because of inertia. The air is not dense enough to push the apple like it did the helium. So it only appears to swing back, but the apple didn't swing back. The van moved towards the apple. The apple didn't move towards the van. So when we release an object here on Earth that's less dense in the air and something that's less dense in the air, it's the same principles. The helium balloon gets pushed up by the air because of pressure, but what's pushing up the air? Because inanimate matter cannot push itself. And the simple answer is the air. So buoyancy proves that there is an upward push. Buoyancy. It's an effect of a chain reaction of push. And buoyancy, again, when I have a ping pong ball in water and it's glued to a slinky, you guys know what a slinky is, right? You can stretch a slinky, right? So if I have a ping pong ball and it's glued to the slinky in water, you can see that the buoyant effect is stretching the slinky. Let me show you. While it's connected to the earth. So you can see that it's stretching the slinky, that buoyant force. As soon as I release it into free fall, that upwards push, that buoyant force vanishes. So the ping pong ball is no longer being pushed to the top of the water.
That's really cool.
So
Thank you for this.
So
Thank
again,
you.
if you guys have any questions before you guys go about this topic, this is the #1 censored topic online, and flat Earth is a psyop as well.
Yeah.
So I'm gonna tell you why flat Earth is bullshit. And
Well, real quick, we are on lunch break. We have to get our lunch, but thank you so much.
here you go. Take this. That's my channel.
Thank you
Yeah,
so
take it.
much.
Thank you.
So just before you go, I guess you're gonna give you my channel as well. But again, motionless, flat earthers are claiming the Earth is motionless, which is a false dichotomy with the globe. They're both claiming downward acceleration.
Claiming a lot of things.
Well, they're claiming a downward acceleration that doesn't exist, just like the globe Earth. That's why flat Earth. Yeah, take care. That's why the flat Earth and globe Earth are both bullshit.
Yeah.
Because the fact is, the Earth is pushing up against you.
Yeah.
That's the reality. So that debunks the whole globe Earth model. That's it. So, if you have any other questions, I'll answer them. But if not, then
What's your name?
My name's William. It's on the fly.
William Cameron.
Yeah,
Nice
appreciate
to
the
meet you, man.
channel.
Appreciate it.
Yeah, thank you.